trigonometric functions and introducing periodic functions. We've already learned this year that functions allow us to model different situations that behave in different ways, and they're used to describe the relationship between two variables, and they have a unique y value for each x value. One example of a function: a rental car costs $44.95 per day plus 10 cents a kilometer. The function that represents the cost C to rent the car, if the distance driven D is known, is C at D equals 0.1D plus 44.95. That's a classic linear relation, and we know all linear relations are functions. We've seen that many times before. Regardless of what value we substitute in for D, we will always get a unique value out for C. Another example: a missile is launched at an initial height of 5 meters and has an initial velocity of 50 meters per second. We can visualize what a missile does when it goes up. It goes up in the air, and then it's going to have to come back down. The function that models the height of the missile in meters at a given time, t in seconds, is known as h at t is negative 4.9 t squared minus 50t plus 5. That's a quadratic function. And we also know that every quadratic is a function, regardless of what value of t I plug in here. I'm going to square it. I'm going to get a unique value. Multiply it by negative 4.9. I'm still getting a unique value. If I subtract the product of 50 times t, I'm still getting a unique value. And if I add 5, it's still unique. So it is still a function. We're going to talk today about periodic functions, which are functions that display repetitive behavior. So something that keeps occurring over and over and over again, follows a pattern. The y values are unique for every x. Okay, so they'll have a pattern which is called a cycle that repeats at regular intervals. And things that have, or examples of periodic events: ocean tides. The tide goes in, the water level goes down, and then as the tide goes out, the water level rises again. So if you're looking at time versus height of the water in the ocean, that's going to be periodic. EEG monitors that measure heartbeat, sound waves, seismic activity, electrical currents, number of hours of daylight throughout the year, or the average number, seasonal temperatures, the average temperature throughout the year, light waves, even someone's height on a Ferris wheel as it turns is a periodic event. Periodic functions have very specific functions. They all have a cycle, which is indicated as one complete pattern in the graph. They all have a period, which is represented by the horizontal length of one cycle. And if you subtract the endpoint of one x coordinate from the other, where the cycle begins and ends, if you subtract those x coordinates, you'll figure out the period. They all have an amplitude, which is a measurement of half the distance between the maximum and minimum, or half the difference, sorry. And the equation of the axes is really the midpoint of the maximum and minimums, and it's a horizontal line, so to speak, that represents the midpoint. If I look at this periodic function here, again, I should have had a screen shade. If I want to figure out the length of a cycle, I'm going up, I come down. I go up, I come down. And that's a cycle from here at 0 to 40 where it ends. That cycle repeats every 40 seconds. So the period is 40. And I could have done 40, take away 0. I could have done 80, take away 40, or 120, take away 80. It will all give me 40, and that is the period. The amplitude, we said, is half the maximum minus the minimum divided by 2. So the amplitude is 30, take away 0, divided by 2, and it's 15. And in this scenario, if we want to find the equation of the axes, we're finding the midpoint. We're finding that kind of imaginary, and I hope I used the right word a few minutes ago. I have a sneaky feeling I might have interchanged my words. It's that midpoint of the maximum min, and we state it as a y equals 2 because it's a line, it's an axis that runs through the midpoint. So it's just 30 plus 0 divided by 2, and you'll notice now we say y equals. And I forgot to mention it, but typically we use A for amplitude, and that relates to something we already know. Anyway, for tomorrow, exercise 2, pages 2 to 3, number 1 and 3 to 5.